So I'm a big believer that the best way to learn a new technology is to build projects with it. By the end of today's video, you'll know how you can build your own AI-powered recommendation app. I'm going to walk you through taking an existing image database and turning it into embeddings, which can then be uploaded to a vector database, which we can then query using embeddings to find other similar records on the database. On top of that, I'm also going to show you how you can use Streamlit to build a front end for your project. So without further ado, let me show you what it is we're going to be building today. So what we're going to be doing is building this pretty simple web app that I've created using Streamlit here, which is basically responsible for finding cats that are similar to other cats. So to demonstrate, if I click on the Find Similar Images button underneath this cat here, what we can see is a bunch of other cats that kind of look similar to the cat that we just selected, or this one at the top here. If I refresh again and maybe choose a different cat, so let's go with this one, we can now see a bunch of cats that look kind of similar to that one, which is pretty cool. So let me walk through step by step exactly what we're going to be covering in this tutorial. So first we're going to find a data set of images to work from. So this is going to be basically a bunch of cats, cat images that I'm going to download from Kaggle. Next, what we're going to do is we are then going to take all of that data and we're going to do a little bit of processing on it. Probably going to want to identify exactly what type of image it is. So if it's a cat or a dog or something along those lines. And then we're also going to want to be able to create a thumbnail image for each one of those images that we can then present to the user on the front end later. Once we have that metadata, what we're going to do is we're going to take the image data and we are then going to run it through a computer vision AI model to then generate what's known as embeddings for each one of those images. I'm probably going to be using embeddings and vectors interchangeably throughout this video, so if I ever say vectors, it means embeddings and vice versa. So once we've created these embeddings, we then need to upload these embeddings to the to a vector database, and we're going to be using a service called Quadrant to do this, which I've used quite a lot in the past, and I absolutely love it. I think it's a really, really great service. The cool thing about uploading all of these embeddings to Quadrant is that once we have all of these vectors stored in our vector database, we can then query this database by passing in a vector of an image to find similar other vectors to the vector that we queried with. If we take this in context of our cat app that we're going to be building, we're basically passing our vector database the vectors of, say, this image here, and it's going to return a bunch of other vectors that it thinks are similar to this to these vectors, which I think is really, really cool. And then finally, once we've uploaded all of our image embeddings to the vector database, we can actually just go ahead and just build a front end to query our database with. And that is just the UI that you are looking at the moment. We're going to be using a library called Streamlit, which I'm a big fan of. It makes building these kind of like data powered applications really, really simple. I'm not sponsored, I just really, really like the product. So yeah, that's what we're going to be covering in this tutorial. So let's get into it. So throughout today's tutorial, we're going to be working in two separate directories. One of them is going to be called IPYNB, and the other one is going to be called Streamlit. To get started, what you're going to want to do is create the IPYNB directory, and then you're going to want to create a Jupyter notebook to write all of your code in. I've called mine get image embeddings, which is the one you can see on the right here. And then you're also going to want to create a .env file. Now, if I open that .env file up, what we have here is two environment variables, one of them called dbURL and one of them called API key. Now, to get these, what you're going to want to do is head over to the cloud.quadrant.io website. You'll need to sign up for a new account for Quadrant, but as it stands, as of 11th of December 2023, you can actually sign up for Quadrant without a credit card and create yourself a free test cluster, entirely free on the free tier, which is really cool, which is what I've done here. So you can see that I've created one here called my test cluster. What we can do is we can spin down this little arrow here, and then we can grab the cluster URL by copying it here to clipboard. And then what I'm going to do is just paste it into the Quadrant DB URL environment variable here. And then to get our API key, you can just head over to data access control, click on create. Then you're going to want to select the test cluster that you just created, hit OK, and just wait a second, and then just grab this API key from the dialog that's just popped up, and then we're just going to paste that into the as the environment variable for the Quadrant API key environment variable, and then we should be good to go. So I've opened up our get image embeddings Jupyter notebook here. What we're going to do in the first step is we are going to go ahead and just import our data set. So what you can see here is I've just put a link inside of this block here, which takes us to the Kaggle data set for animal faces. This is the image data data set that we're going to be using throughout this tutorial, which is just thousands and thousands of pictures of various different animal faces, which is great. It's about 750 meg, and you can download it from the Kaggle website just here. So I've done that already, and what I've done is extracted it and put it into the IPYNB directory that I was talking about here, and it's extracted as this AFHQ directory here. If we spin that down, we can see that there's two data sets. We've got the train data set and we've got the evaluation data set, and they've been split into cat pictures, dog pictures, and wild animal pictures, which is great. For this tutorial, we are just going to be working with the cat images, but if you wanted to and you have maybe a little bit more processing power than me, you could use the entire data set and upload all of every single one of these embeddings of every single image to Quadrant, but in this tutorial we are just going to be using a subset of the data. So what I'm doing here is just creating a variable called base directory, which is just going to point to where all of the cat images lie. Then I'm going to create another variable which is just going to be a list of all of those images inside of that directory, and it's just going to be the image names. It doesn't have the paths yet, and then I'm just going to log the first 10 of those to the output. So if I hit play, you can see that's come through exactly as we'd expected. If we spin down these, we can see that those are the images that we expected to see. In this step, we're going to grab the first 500 items from that array that we just created in the previous step, which is just the names of all of the files, and then we're going to then create full directories, of every single one of those images, just so that we can reference them easier in our future steps. So here we create a new variable here called sample image URLs, which is just going to pull the first 500 of those URLs from the list that we created in the previous step. We are then going to iterate over every single one of those by mapping over it. So we're calling the map function and then passing the sample image URLs as our second argument. And then we are passing in a lambda, which is basically just going to construct the full directory for each one of those file names that we created in the previous step. And then we're just going to log the output to the console. So if I hit play, we can see that every single one of these outputs is now the full directory path of the file that we had created in the previous step. So I'm just going to double click here just to collapse those outputs because that's quite long. And then we're going to move along to the next step. So what we're doing here is we are basically going to create a data frame out of that data that we've just created, just to make it a bit easier for us to manipulate in the future. We're going to import a data frame from the pandas library, and we are also going to import the image component from the pillow library. And then we're going to initialize a new data frame, and we're going to initialize it from a list of records. We're going to set the column name to image URL, and then we're just going to pass in the array of image URLs that we actually created in that previous step, which is going to be our 500 image URLs. We're also going to set the type of every single one of the, we're going to create a new column, which is going to be called type, and we're going to iterate every single record inside of that data frame, and we're just going to assign it to cat because we know that every single one of those rows is going to be a cat. And then we're just going to log the output to the output. So I'm just going to hit play, and we can now see that we have a data frame. It's got a column with an ID, we've got the column with the image URL, and we have a column with the type set to cat. So that's looking great. Next, what we're going to do is iterate over every single one of the image URLs inside that data frame that we created, and then we're going to then create pillow images out of every single one. So here I'm just initializing a new variable called images, where once again calling the map function, and we are passing in payloads image URL, which is just an array of every single one of the image URLs from that data frame that we created in the previous step. And then we're going to pass in a lambda as the first argument, and we're just going to call image.open, and we're going to pass in that URL that we created from the in the previous step. So we didn't need to import pillow again because we had imported it in the previous step, as you can see here. And then we're just going to log the output to the console. So if I hit play, you can now see that we have an array of pillow images. Next, what we're going to need to do is create a base64 representation of that image. And the reason that we need to create that base64 image is because we need to somehow be able to show a preview to the user on the front end exactly what the image looks like. And we're not going to be able to get that from the vector embeddings that we're going to be uploading to our Quadrant database. And so the way that we could do that is, one, we could basically go down the path of uploading every single image to, say, like an S3 bucket or to a server somewhere, or we could go down this route, which is what I've suggested, which is basically create a base64 string representation of every single image, and we're going to upload that to the database as as part of the metadata of each of the records. It's just going to make it a lot easier for us to be able to grab that data in a nice convenient place and then show it on our front end. So the first step, what we're going to do here is we're going to import the Bytes.io component from the IO library. We're going to import the math library, and we are also going to import the base64 library. Now I want these thumbnail images to have a width of 256 pixels, so I'm going to set the target width here to 256, and then we can get into declaring these two functions here, one called resize image, another one called convert image to base64. No prizes if you guess exactly what they do. So resize image is going to take an image URL parameter, or an argument, sorry. That is going to be a string, and then what we're going to do is just like in the previous step, we are going to create a new PIL image with, once again, using Pillow, and we're going to call image.open image URL. We've actually already imported the image component in the previous step, so we don't need to import it again. Next, what we're going to do is assert the image's aspect ratio by dividing the width of the image that we just loaded up by the height of the image, and then we're going to then call the resize function on that PIL image that we just created, and we're going to assign it to a new variable called resized PIL image. This function actually takes a tuple with the first item inside that tuple set to the width, or the target width, and then the second item in that tuple is going to be the height. So we're going to pass in the target width as the width, and we'll set the height to the target width multiplied by the image aspect ratio, which we asserted in the previous line, and then we're just going to floor that to the nearest whole number. And then finally we can return that resized PIL image at the end of this function here. Okay, so this next function is called convert image to base64, and this time this is going to take one argument, which is going to be the PIL image. First, what we're going to do is create a new variable and call it image data, and we're going to create a data buffer here using the Bytes.io constructor. What we're going to do is save our image data into that buffer by calling the save function on the PIL image that we're passing into that function, and then we're going to pass in the image data, which is the buffer that we created in the previous line, and then we're going to pass the formats to be JPEG, because we know that all of the images that we're working with are JPEGs. And then we are going to create a base64 string out of that image data that we just created, and the way that we do that is by calling the b64 encode function on the base64 library, pass in the image data that we just created in that previous step, and then we're just going to decode the result of the b64 encode function to a UTF string, which we can safely return at the end of that function, which is going to be our base64 representation for that image. And so now what we can do is we can actually combine all of these steps together to then create a list of base64 strings or base64 representations of every single one of the images that we've created so far. So first, what we're going to do is we're going to create an array of resized images. So to do that, we are going to map over our sample image URLs here, and we're going to pass in a lambda, which is going to be basically calling the resized image function over every single one of the items in this array. And then finally, we're going to cast that to a list. And then in this following line, we're then going to create base64 strings out of the resized images that we just created. So you can see here that I'm calling the map function again, passing in the resized images as the second argument this time. And then as part of our lambda, what I'm going to do is just call the convert image to base64 function that we just declared on every single item inside of that array. And then finally, just like before, cast the output to a list. And what that does is that basically gives us a big list of base64 strings. And what we can then do is, because we know that they match the same sequence as the data frame that we were working in, we can actually create a new column, on our payload's data frame and call it base64. And then we can just assign it to a list of all of the strings that we've just created. And then we're just going to log the output here. So if I hit play, that might take a little bit longer, but you can see that we have the image URL, we have the type, and we do have all of those base64 strings, and they've been generated just as we expected. So now that we have this big list of PIL images, we can actually now create embeddings out of every single one of those. So to do that, in this step, what we're going to do is we're going to import the auto image processor and the ResNet for image classification components from the transformers library. We're going to declare a new processor, which is going to be initialized from this auto image processor. processor, and we are going to pass in the model Microsoft ResNet 50. You can use whichever embedding model you would like to, but I've found that ResNet 50 seems to work really well. And then once again, you also want to create a model variable, and we're going to call that ResNet for image classification component, again from pre-trained, using that exact same model string that we used in the previous step. So next, what we need to do is we need to call our processor on our images to then create a list of inputs that we can then put into our model. So that's exactly what we're doing. We're calling processor, we're passing in that list of PIL images that we created a few steps ago, and we're just making sure that we are returning PyTorch tensors. And then once we've done that, we can actually go ahead and pass those to our model. So we're going to assign a new variable called outputs, and then call the model and pass in our inputs here. And then finally, we can actually just grab the embeddings for every single one of those images that we are processing, and then just log the embeddings to the console. Now, this step is likely to take a lot longer because we are passing in a lot of inputs. We are passing in 500 images at the same time. There are ways that you can batch this to be more performant and basically be able to manage and process a much larger data set at the same time. Because this is a much more simpler tutorial, we aren't going to be doing that right now, but if you do want to know exactly how to do that, you can consult the Hugging Face documentation. They've got loads of information on how you can go about batching this data to do this in a more efficient manner. So if I hit play, what's going to happen is this is likely to take around a minute, for me anyway, running on a MacBook. Okay, so that took me about 1 minute and 8 seconds to process almost 500 of these images, and you can now see that the tensors have been output exactly as we had expected, so that is working great. So in the next few steps, what we're going to be doing is uploading all of those embeddings that we just created, so all of those vectors, to our Quadrant database. So to be able to do that, we first need to understand exactly what the length is of the embedding that we just created. And so the way that we do that is super simple. We can just call the len function on the first item inside of our embeddings, which will give us the length of all of the embeddings. So if I hit play, we can see that every single one of these items has an embedding length of 1000, which we'll use in the next few steps. Next, what we're going to do is we are going to import those environment variables that we set up at the beginning of the tutorial. The way that we do that is by importing the .env library, and specifically importing the function load.env. This is just going to load all of those environment variables into our current environment so that we can access them inside of our Jupyter notebook. So I'm just going to hit play here, and we can see that that's returned true, which means it's found our .env file and it's imported our environment variables. So now what we can do is actually initialize our Quadrant client using the environment variables. So first, what I'm going to do is import the Quadrant client component from the Quadrant client library and import OS. The reason we need to import OS is because this is how we actually get the environment variables. So you can see we're initializing our QClient variable here by calling Quadrant client. We're going to pass in two parameters. One is going to be the URL and one is going to be the API key, where URL is the Quadrant DB URL environment variable that we set at the beginning, and API key is the Quadrant API key that we also set up at the beginning. And then we're just going to log that client to the output. So if I hit play here, we can see that seems to have initialized the Quadrant client exactly as we had expected. So next, what we're going to do is we're going to create a collection to store all of our embeddings and our metadata in. And so to do that, we're just going to import vector params and distance from the Quadrant client models library here. And then we are going to just declare a new collection name, which is going to be the name of the collection that we want to create on Quadrant. So here I've just called it animal images. We're going to call recreate collection on our QClient instance that we actually created in the previous step. And we're going to pass it two arguments. The first one is going to be the collection name that we've just initialized here. And then we're going to pass in a vectors config, which is going to be these vector params here. These vector params are going to take two arguments themselves. One of them is the distance, which is distance.cosine, and the other one is going to be size. Now, size is that embedding length that we actually initialized a couple of steps up on step 7 here. So that's why that was important. And then what we can do is once that's been created, we can then just log that to the output. So I'm just going to hit play here, and we've got true, which means that this collection was created successfully. Next, what we're going to do is we're going to convert all of the rows that are inside of our data frame and convert them to a list of dictionaries, which we can then upload as metadata to each one of our quadrant records. And so to do that, what we can do is assign a new variable called payload dicts, and then we're going to call the toDict function on our payloads data frame that we created a few steps ago. And we're just going to make sure that we set the orint parameter to records. That's just going to make sure that the output comes out as a list of records. So I'm just going to hit play here, and we can see the outputs are collapsed because I would imagine this is going to be quite large. It is. So we can see we have the image URL, we have the type as cat, and then we have the base64 strings that we were creating earlier. But as you can see, I mean, we don't need to go through every single one. You can see that this is an array of dictionaries formatted in a JSON friendly format that we can actually put as metadata on our quadrant database. So I'm just going to collapse those again and move on to the next step. So to do that, what I'm going to do is I'm going to import models from the quadrant client library, and then I'm going to initialize a new array, and I'm going to call it records. Now, from the way that we've been working, we know that our payload dictionaries and our embeddings follow the same sequence as each other. That means that when we enumerate over our payload dictionaries and then grab the index for each one of those items in the loop, we know that we can safely use that same index for our embeddings, which leads us on to the next step. So inside of that loop, we can then create a models.record using the quadrant client imported models that we did earlier on. And then what I'm going to do is I'm going to set the ID to the index. I'm going to set the payload to the payload dictionaries index, and then I'm going to set the vector to the embeddings index. So this is all, like we said, they all share the same sequence, so we can comfortably use the same index for both arrays. And then I'm just going to hit play to then create all of those records. And then finally, we actually just have one last step, which is just going to be to upload all of those records to that creation that we just created in the previous step. And so to do that, we can just call qclient.uploadRecords. We're going to pass in the collection name, and then we're just going to pass in those records that we just created. I'm just going to hit play. Okay, so that's now finished. It took just under 20 seconds. Next, what I'm going to do is just check to make sure that all of that data has gone up to our quadrant database as we expected. So to do that, I'm just going to head over to cloud.quadrant.io. I'm going to click on this little arrow to spin down my cluster, and I'm just going to click on Open Dashboard. And then I'm just going to hit paste, which is going to be the API key that I mentioned earlier. And that now means that we can now access all of our collections on our cluster. Now, I've got a couple of other ones on here from other tests that I've been doing, but the one that you can see that we've just created, which is called animal images, I can click through to that. And we can now see that we have the payload and the vectors uploaded exactly as we had indicated. So we have the image URL, which is the local image URL we were using at the very beginning. We have the type, which is that other column that we created, and most importantly, we actually have the base64 string. And then what's cool is we actually also have the vectors, which is our embedding for every single one of these images, and these are all successfully uploaded. So now that we've uploaded all of our embeddings to Quadrant, we can now go ahead and start building our front end. So we've just been working inside this IPYNB directory, but now what we're going to be doing is working inside of this Streamlit directory. So if you don't have one already, do create a Streamlit directory inside of your parent directory. And then what you're going to want to do is create a directory called .streamlit. You're going to want to create a file called app.py, and you're going to want to create a file called requirements.txt. Inside of requirements.txt, we just need to put Streamlit and the Quadrant client. That's all we're going to need. Next, what you can do is inside of .streamlit, we can then create a file called secrets.toml. Now, this is not too dissimilar to that .env file that we actually created in the previous part of this tutorial, which stores all of our environment variables. And when I open it up, you can actually just see that I've left these two placeholder environment variables. We've got the Quadrant DB URL and the Quadrant API key. So it's exactly the same as we were dealing with earlier. What we're going to do is we're going to hop over to our .env file from the previous part of this tutorial. We're going to grab the DB URL and copy that, and then we're going to paste that into the section for our Quadrant DB URL environment variable. And then we're going to do the same for our API key. So I'm just going to copy the API key here, and then I'm just going to paste it into this section here. Okay, so now that your environment variables are all set up, you'll want to hop over to app.py or create yourself a new app.py if you don't have one already. And then what we're going to do is we're going to import all of the necessary libraries that we require for our front-end Streamlit app. So first we're going to import the Quadrant client component from the Quadrant client library. We're also going to import the Bytes.io component from the IO library. We're going to import Streamlit as ST, and we are going to import the base64 library. We're going to need to somehow access our Quadrant collection that we've just uploaded all of our data to. So right at the very beginning, what we're going to do is just declare a new variable. We're going to call it collection name, and we're going to assign that to the name of our collection where all of our data is stored on Quadrant, which is animal images. So to explain the next two steps, let me head back over to our Streamlit app. So this is going to be the final project. If I click on the Find Similar Images button, what you'll see is we now have this image of the cat that we just selected and a banner that appears, which basically says images similar to. When we click on the Find Similar Images, what we're actually doing is we're selecting the image of that cat to then query our database with. And so if I tab back over to our app.py file, what we're doing here is we're actually just basically initializing a selected record state using st.sessionState. So what we're doing is if selected record is not in st.sessionState, then make sure that we're basically setting our session state selected record to none. That basically initializes that session state variable that we can then reuse later on throughout the rest of the app. And then keeping in with that, what we're going to do is we're going to create a convenient function that we can use to basically set our selected record. In this case, it's going to be every time we click one of these similar images button, we're going to be setting the selected record to whichever cat we just selected. So we're going to create a function called set selected record, and we're just going to pass in a new record, and then this is just going to set the session state selected record variable to new records, which is passed into this function here. Next, what we're going to do is we're going to create a function which is going to be responsible for creating and fetching our Quadrant client. We're basically going to initialize a new Quadrant client instance, and we're going to pass it the URL and the API key. Both of these are going to be fetched from the secrets, which are the environment variables that we set up inside of our secrets.toml file earlier on. So we're going to go URL equals st.secrets.get, and then we'll pass in the environment variable name quadrantdb URL, and then we're going to do the same here for API key, where we'll go st-secrets get quadrant API key, and that will then initialize our Quadrant client. The only thing to note here is on line 22 we have this decorator which basically says to our Streamlit instance, make sure you are caching this client, because we basically don't want to have to recreate it every single time Streamlit refreshes its content. We want to make sure that this Quadrant client is created once and then never recreated again, and that is what this decorator does here, stcache resource. Cool. So to demonstrate this next function that we're going to be writing, which is called get initial records, I'm going to head back over to the app again and I'm going to refresh it. When you first load the app up, you'll see that there are some initial cats. These are just a sample of some cats that you can select to then get you started on your journey to finding similar images to other cats, for example. So what this function is actually responsible for is just getting those first records. And what we're going to do here is we're going to declare a function here called get initial records. The first line is going to just get the client. That's the function that we just created in the previous step. And then what we're going to do is call the scroll function on our client. We're going to pass in our collection name. We're going to say that we do not need the vectors because we actually just need the metadata right now. And then we're going to set a limit of 12. So this function, all it's doing is calling the client, getting these initial records, and then returning them. Nice and simple. This next function is called get similar records. And I would imagine you've probably picked up exactly what this is, but just in case you haven't. So I'm heading back over to the app again. If I click on find similar images, we are going to see all the images that were similar to that cat that we selected. This function is responsible for fetching all of the records from Quadrant that are similar to the object that we selected. So if we head back over and have a look at the get similar records function itself, we're going to call the client. So get the client in exactly the same way as we did in the previous step. This time what we're going to do is we're going to check to see if our session state selected record is available. If it is, that means that we have selected one of the cats that we want to find similar cats to, and we can use the selected records to then look up using Quadrant any other similar similar cats. So what we're going to do is call the recommend function this time on our client instead of the scroll function. And we're going to pass in our collection name, and we are going to pass in an array into positive, which is going to be the selected records ID. And once again, we're also going to set the limit to 12. So let's just talk about the positive line before we move on. So this is going to be an array of IDs that we want to find other similar records to. So at the moment, we are only passing in a single ID, which is just going to be the selected record. So like I said, if I click on the find similar images here, we're actually just going to find similar images to this cat's ID. But let's say, for example, let's say we wanted to find cats that were similar to this one and similar to this one and similar to this one. We could pass the IDs of all of those cats to our quadrant client, and it would be able to fetch all the cats that are similar to or share similarities to all of the cats that we have selected. Right now in this demo, like I said, we're going to be working with one ID, but just so that you know for the future, that's more that you can do. You can also, just to extend very quickly, you can also pass in a negative array, which works in exactly the same way, but the opposite. So if you want to find cats that aren't like a specific cat, then that's the array to basically pass it into. So yep. So that's all the get similar records function does. It's just going to grab, or it's going to get the client, it's going to find cats that are similar to the currently selected records, and it's going to return them. Next, we're going to declare one last function, and this one's just going to be get bytes from base64. We're going to pass it a base64 string, and all it's going to do is it's going to create a buffer out of the base64's decoded base64 string. So that will create an image buffer that we can then render on our Streamlit app. So you might have observed that we've actually just been writing functions all the way up until now, but from here on out, so from step 8 onwards, we are going to be writing the code to actually render our Streamlit app. So to get started on line 72, we're going to basically create an array of records. These are going to be the records that we show on the screen at any given time. So these records here, these are all of the cats that are similar to the cat that we've selected. This records array could also be that initial records array that we show when we first load the app up. Let's have a look at how we're assigning that. So we're going to go records equals get similar records if the session state selected record is not none. So if we have selected a cat that we want to find other similar cats to, then we are going to call the get similar records function. But if we haven't set a selected record, which means we've just started the app up and we haven't clicked on a find similar so far, we're going to call the get initial records function. So in this step, in step 9 here, what we're going to be building is we're going to be writing the UI code which renders this chunk right here, which is going to be our banner, which basically says images similar to, and it's also going to show the selected cat image. So on line 77, we go if st session state selected records. That basically checks to make sure that we have actually selected a record. What we're going to do is we're going to call that get bytes from base64 function that we declared earlier to basically get the image bytes for the image that we are going to be rendering. So we're going to go st session state selected record. We're going to grab the payload, and then we're going to grab the base64 string. Now this is the base64 string that we uploaded to our metadata earlier, and again, this is kind of now where this preview base64 is going to start coming in handy, because it's attached to every single record's metadata that we've got. We're also going to render a header here, and we're going to go to do that. We just go st header, and then we're just going to pass in the string that we want to render. And so as you can see, it's images similar to, which is this section here. Then what I want to do is I want to render the image of the cat that we have selected. Again, super simple, st.image, and we're going to pass in an image property, and we're going to pass in the image bytes that we've just generated from the base64 string in the previous line. And then finally, we're just going to render this gray divider here just to break up the page a little bit so that there is a separation between the similar cats and the cat that we've just selected. This next step is super simple. We're basically just going to be setting up our columns that we're going to render our cat grid into. So we're just going to go column equals st.columns, and then we're just going to pass the number of columns that we want, which is 3. So we actually only have one chunk of code left to basically finish our app up, and this is just step 11. What we're going to do is we're going to enumerate over those records so that we can get the index as well as the contents of each of the records that we are enumerating over. Next, what we want to do is understand which column index do we want to put our cat into that we are currently enumerating. And to do that, we can just use the modulo operator, which is the little percentage here. We're just going to declare the column index as col index. We're going to use that index again that we've gotten by enumerating over our records. And then we're just going to use the modulo operator and use the number 3, which is the number of columns that we are trying to work with here. Next, once again, we need to show a preview of this image. So we're going to call that getBytes from base64 function once again, passing in the records payload, and again using that base64 string that we uploaded to our payload on Quadrant earlier on. And then we're just going to cache that into a variable called image_bytes. And now all that's left is to actually just render our cat image and our button that we're going to use to find similar images to that cat. So to do that, we're just going to go with column, and then we're going to pass in the column index here that we identified a few lines ago. And then we're going to use st.image to render the preview image of our cat. And then we're going to add a button with st.button. We're going to set the key to the ID of the record. We're also going to pass in an onClick function, which is going to be set selected record, which I'll talk about again in a second. And then we're also going to set the arguments, or pass in the arguments, which is just going to be the record. So let's go through these two lines specifically, just because it's a little bit confusing if you haven't used Streamlit before. So we're passing in the set selected record function. So if I just head over to that, we can see that we've got the set selected record function that we created earlier on. And what this is responsible for doing is basically setting the Streamlit session states selected record to the record that we pass in. Now you'll notice that as I mentioned before, we are passing the record in as an argument, and that is where this other array comes in just here. So on line 103, we're passing it an array of arguments ultimately that this function here, the set selected record function, will use. And because we only have a single argument, which is the record that we want to set to find similar cats to, we just need to pass in an array which contains the record that we are currently selecting. And because we are iterating over it, we can just use that record from within our loop and then pass it in as a single item inside of our arguments array. So now we can click on find similar images on, say, like this cat. It's going to then render this chunk of code here, which is just this little preview section, which gives us the little title and a preview image of the cat that we're looking for. The records array is going to change to find similar records to the cat that we've selected, and then this last chunk of code here is going to render a grid of cats that look similar to it. So let's just scroll down. And yep, that's a bunch of cats that look kind of similar to this one, or at least have similar features to the cat that we have. And that just about wraps it up. If you're still here and you enjoyed this kind of content, I would really appreciate it if you could drop me a comment just to let me know. I really liked making these kind of sort of like workshop-y project videos. So if you want to see more, then please do let me know in the comments. Thanks again for watching, and I will see you in the next one.